Okay, so welcome to my CNET CCNA ICND1. I believe we're looking at exam 100-101. In this video, we're looking at chapter 18 of the Odom book, Configuring and Verifying Host Connectivity. And that's going to talk about things such as how to configure DHCP on a router, looking at verifying host address settings on a PC, and then looking at how to test connectivity using commands like ping, traceroute, and telnet. So your PC comes online. How do you get an address? Normally, what happens is a four-step process. A PC comes online, and you send a broadcast to your LAN going, hey, I need an address. Where is the DHCP server? And then the server will respond with an offer address, which will be a unicast, back to the client. But in this slide, we don't get justice. In reality, so step one, we already talked about discovery. It's a broadcast. The server responds back with a offer, which is unicast. But then, the third step, it will be sent back to the DHCP server as a DHCP request. Again, as a broadcast. The DHCP server will respond with a DHCP ACK, which will be unicast. That way, you will get your address. So it's not just discovery and offer. It's discovery, offer, request, acknowledgement. Those are the appropriate four steps. But what happens when your network does not have a DHCP server local? Can you actually have it as a separate device on a different network? Sure. We have what's called an IP helper address. Basically, the same steps will just be applied, but we'll send it to our router. Our router will actually then forward it to the helper address. The helper address will respond with the offer and their acknowledgement, same way it happened if it was local, but here it's not tied specifically to our local network. And here again, the offers do come back from our remote DHCP server. So let's talk about some pre-configuration. We need to think about, well, what network are we going to have, first of all? Second of all, what static reserves are we going to have? Are we going to have any excluded addresses? The static reserve might be if this MAC address comes online, assign them this IP address. That's different from an exclude, because the exclude will just say, do not use these addresses. Next, our default gateway / router address. And we could also set up things like a DNS server. We could also set up things like a domain name and a lease time if we wished. So we have options. So that the server configuration, again, we set up exclude. We'll have a pool of addresses. That's what we're going to be assigning. The pool should be our network ID with subnet mask minus our excluded address list. Default gateway, DNS, lease time, domain name. We already spoke about that. So let's look at if we're going to set R2 as our DHCP server. So we're going to have a left side and a right side. Notice the left side network. Notice the right side network. So first thing is we set up our exclude. That's for the left. Because again, notice the network ID. Notice the address. So here we're saying on the left side, we are not going to use 1 through 50. On the right side, we're not going to use 1 through 100. So now we set up our pools. We do IP DHCP pool. We do it with the appropriate name, the network, subnet mask, DNS, default router, or default gateway, lease time, days, hours, minutes, and a domain name. Same steps for our second pool. So see, this is the weird thing. We talk about creating the pools. We have not assigned the pools an interface yet, meaning they will not go out a specific interface just yet. We have not got that far yet. Do not do a slash notation. The DHCP sometimes likes them, sometimes doesn't, so we gotta be careful with those. Alright, how do we verify it? We can verify it two different ways. If we're looking at specific binding, we could look at show IP DHCP binding, and that will show you the IP addresses that are currently leased. If we want to look at the overall status of a pool, we can do show IP DHCP pool and the name. So again, here's the binding. Here's the pool and pool name. That way they can yield us different information. For example, we want to see the utilization, high and low. We want to see the current subnet. How many addresses do we have? What about our lease time? That way we can kind of see. Also, this will show us current subnets that are active in our pool. So if we do a show IP DHCP conflict, we can actually also see the conflict, just in case we get a conflict issue. That's rarer, but I mean, it does happen. If we want to manually do this on a PC, this is going to go more with the address settings. Okay, so this is being done on a Mac, and you're going to notice the configure IP is set to manual, that's static. And so you assign the IP, the subnet, the default gateway, but you'll notice the DNS is not static. It won't allow you to enter it. If we change the manual, the DHCP, it'll function. But also notice, we have different interfaces. So currently we're configuring the Ethernet interface. If we want to configure the Wi-Fi interface, we'd have to click on the Wi-Fi. It's important to realize that we configure these based off of per interface. On a Windows machine, we could do an ipconfig -all, and we'll get all the detailed information that way. ipconfig all. And it's going to show me all of my interfaces. Here is my local area connection. Happens to be that this is a virtual adapter for Juniper, so we're going to scroll down a little bit. Here's my real physical adapter. My MAC address, my currently preferred leased IP address, my lease, my DHCP server, my DHCP version 6 server, my DNS servers. So this gives me specific information that was already pre-assigned to me. But what about, I want to go to a website. What happens there? What ends up happening is a three-step process. I want to go to Google. I type google.com. That's the first step, google.com. Second step, it has to be translated back to an IP address. So a DNS server will send me back the name and IP address for my resource. Google.com equals this IP address. Then I go to that IP address. So I'm going to open back up my command prompt. Ping google.com. And again, that process is fairly quickly. It translated google.com to the IP address of 216.58.219.14. So it actually completed all three of those steps fairly quickly. But I want to see if I can find other addresses for Google. So I can do an NS lookup. Google.com. That will give me Google's.com's current address, www.google.com. Oh, notice the addresses are different from Google.com and www.google.com. What about Google misspelled? Again, same thing. You're going to notice that we're getting different addresses, or we have the ability to get different addresses depending on what we type in. But you'll also notice that we're only getting one response. That happens to be because our server, our DNS server, is limiting our responses to just one. But if we do an NS lookup, we should get the server and the port number. So server, port number, it's responding on. And then we'll actually get the domain name and the IP address of our resource. So this is going to be our DNS server information, and this will be our response to our domain and its IP address. What about netstat? What's netstat? Netstat will actually show you inbound and outbound connections. So I'm going to go back. So I'm going to start with just netstat. It will show you both the local and foreign addresses and their current state. So all of the connections that I have, if I have an open web page, if I have a specific anything open, it's going to show those connections. I happen to have a website open and Outlook, so it's actually going to start loading up all of my connections. But what about all of the switch commands? I want to see netstat with a question mark. So we have lots of different options. A will show all the options, O will show the process ID, N might show the address and ports, R will show the routing table, S will show the per protocol statistics. So here in our example, netstat-rn, that will both show our routes, but I also want to do S. Give me all the routes, but I also want to see statistics on packets received and packets delivered, errors. What about, I don't know. So these get more complicated depending on what you want to see. Oh, I think I scrolled too far. Yeah, here it is. RNSO. So you play with these. Maybe you don't do all of them. Maybe I just want O now. They're all going to do different results that are going to give us different material. O will show you the process IDs. That way you can see what process IDs are using these. Maybe to track down an intrusion. Each netstat command has a specific reason. Alright, so moving forward is how do we get MAC addresses local? We get them via ARP, Address Resolution Protocol. And we can get them both locally and remotely, like if we need to leave the network, we're going to get the MAC address of our router. And we do that by going to the command prompt and typing ARP-A. And again, let's just do ARP for now, and we're going to see that we can't just type ARP. There's lots of other options. So I want to do ARP-A, and that will show us our current mapping of IPs to MAC addresses and how they are learned, dynamically or static. If we're looking at ARP tables on a router, we're going to see again which interface they're learned off of, things like that. Moving on, we have an ICMP, or a ping, P-I-N-G, and how it really functions. So ping is really just an ICMP protocol. ICMP consists of two things, an echo request and an echo reply. Essentially, are you there? And then a reply, yes, I'm here. So what we do is we send a ICMP to a destination or remote host, and then if they get it, they will respond. Hence the echo request. It will be sent that way. The PC will get it. It will then respond with a reply going that way saying, yes, I am here. Normally you'll see something like this when you ping. You'll end up with time in milliseconds. You may also end up with things like the minimum, the average, the maximum, and a standard deviation. If we sent 6, we should receive 6. If we do it from a router, same general concept, but you'll notice maybe the first one may be a 0. I totally did not circle the 0. That's because the first time you go to do this, you have to send out an ARP request, hey, what's the MAC address of this IP? It may take a second, so the first one gets dropped. That's why if you're not sure if it functioned or not, ping again a second time to make sure that all 5 of them get succeeded. That's why up here, 1 of them was dropped. Only 4 out of 5 were responded. We can do this per interface. We can do it based off of this interface right here, or this interface here, and the responses will be different. Here, that's our source address, that's our destination address. Here, this is our source address, here's our destination address. So there are different ones. If we're looking at ping, normally ping in the IP address, and we can play with some more of the settings if need be, but normally ping in the IP address works just fine. Next, traceroute. How do we get from here to here? Well, in this diagram, we could go 1 step, 2 step, 3 step, or 1 step, 2 step, 3 step, 4 step. So traceroute allows us to see the route that our packets are taking. Again, traceroute and an address, and I'll give you the step-by-step. traceRT google.com. And then it'll take a second or two, but it'll trace all of the hops between us and that resource. And our trace route is complete. It went from me, and it took 8 different hops to get out to the internet. 4 of them happened to be our school's internet connection, and then once we left the school's internet connection, then it had to go through 4 additional hops to get to Google. And so how do we make sure traceroute doesn't live on forever? We set a TTL, but the problem is we have to set a TTL at the appropriate size. Normally, it's set to 15. In the traceroute we just did, it was set to 30. Here, if we set a TTL to 1, just getting from the PC to the router, it will die, because our calculation is TTL minus 1 will equal our new TTL. Meaning, here will be 1, the router will get it, subtract 1, and it goes to send it out, it'll have a TTL of 0, and if a router has a TTL of 0, it just gets dropped. Here we have a TTL of 2. It can go 1, 2, and it gets to that interface, and then dies. Because again, here we have a TTL of 2, it gets to that interface, gets to 1, gets sent out that interface that way, minus 1 again, so our TTL of 2, we minus 1, TTL of 1, we minus 1, we have a TTL of 0, the router drops it. Here's a trace route. If we do it from a router, we may have additional information that we could add. Doesn't always happen that way, but sometimes it does. Lastly is our telnets. How do we remotely connect to our devices? Could we have Bench connecting to Milwaukee, or Euchre connecting to New York, and then Bra connecting to this guy? Sure. We telnet to it. Telnet is plain text, so not very secure, but we'll telnet to the device, or IP. If we're allowed access, it may prompt us for a username and password. If we're jumping around, we could actually press Control-Shift-6, and that should temporarily suspend our connection. Here, if we are looking at a router, we can do session, and that will show us all of the suspended telnet sessions. If we type where does the same thing as the session option, just a different way to do it. Here we have the different connections, so session 1, session 2. If we do resume and a session number, we will resume one of the appropriate sessions. And again, we can disconnect specific sessions. Disconnect and the session number. And that's actually it for this chapter in a nutshell. Thank you.